The proof of the external division formula is very simple. Let this be our line ABC on the xy coordinate plane. Point C divides the line segment AB externally. Let the coordinates of point A be x1, y1 and the coordinates of point B be x2, y2. Let the coordinates of C, which we are supposed to find out, be x, y. To find the x-coordinate of point C, we use the same technique we used for the internal division proof. We draw the perpendiculars from all 3 points onto the x-axis. They meet the x-axis at point P, Q and R. As all points lie on the x-axis, their y-coordinates will be 0. And the x-coordinates of each point will be same as the x-coordinates of points A, B and C respectively. The coordinates of point P will be x1, 0. Point Q will have coordinates x2, 0 and point R will have coordinates x, 0. We know that AC upon BC is m:n. So with this information, we need to find the coordinates of point C. The ratio AC by BC is m:n. As all 3 lines are perpendicular to the x-axis, they would be parallel to each other. AC and PR are transversals to those 3 parallel lines. So according to the theorem of intercepts made by 2 transversals with 3 parallel lines, we can say that AC by BC is also equal to PR by QR. Finding PR and QR is easy since all 3 points P, Q and R lie on the x-axis. This is PR. We know that length of PR will be x minus x1 and length of QR will be x minus x2. If a line segment lies on the x-axis, then its length will be the difference of the x-coordinates of the endpoints. Cross-multiplying, we get mx minus mx2 equal to nx minus nx1. As we want the x-coordinate, we have to get all terms that have x in it to the left-hand side. Transposing this term here, mx minus nx will equal mx2 minus nx1. The difficult part is over. Now it's pure algebra. Since x is a common factor on the left-hand side, we write x multiplied by m minus n equal to mx2 minus nx1. Transposing m minus n to the other side, the x-coordinate will equal mx2 minus nx1 divided by m minus n. This tells us that given the x-coordinates of the endpoints and this ratio, we can find the x-coordinate of the point that divides a segment externally. What about the y-coordinate? By drawing perpendiculars to the y-axis in a similar manner as before, we get the y-coordinates as my2 minus ny1 divided by m minus n. These two are the coordinates of point C. Given the ratio of m:n and the coordinates of the endpoints of the line segment, we can find the coordinates of the point that externally divides the segment.